Hey guys, today we are going to be working on solving simple equations. That's section 1, chapter 1 for Algebra 1. Lots of ones going on today. So what we're going to be looking at today is starts with some vocab. We're going to get into how we work with addition, subtraction, multiplication, and division, and then finish up with some word problems. Starting in box 1, our vocab here, we're going to start very basic, an equation. An equation is just a statement that two expressions are equal to each other. Now we know that an expression just is some mathematical statement. It could be a number, it could be a variable, it could be a combination of those two things. So an equation really is just taking two of those statements and saying, hey, these two things are equal to each other. This chapter we're specifically focusing on linear equations in one variable. So we'll get, as we go through the rest of the chapters, we'll talk about what it means for something to be linear. What you need to know is just that when I have my variable, if it's x or n or d or whatever we're using, there's not going to be anything else happening to it other than our four main operations, which would be addition, subtraction, multiplication, and division. So moving along, next talking about a solution. A solution, that's what most people would call the answer to the problem. The technical definition is a value that makes my equation true. So I have a number in there that I could substitute back in for one of my variables, and it makes my equation true. Next, we're getting into a little bit more about how we're going to be working with equations. We talked about our four main operations, being multiplication, division, addition, subtraction. Inverse operations are when we have two of those operations that undo each other. So they kind of cancel out what the other one does. So our main ones that we'll use, again, with those four functions, addition and subtraction, are inverses of each other. And then multiplication and division are also inverses of each other. Because if you did those operations with the same value, they're going to cancel each other out. Like if you added 2 and then subtracted 2, you undo each other and they're really left back with what you started with. Same thing happens with multiplication and division. If you multiply by 2 and then divide by 2, they just cancel each other out. So that's why those two operations are inverses of each other. When we go through and start solving equations, our goal for solving an equation is to isolate the variable. We're trying to get whatever it is that we're trying to solve for all by itself with nothing else on that side of the equation. All the numbers we want on the other side of the equation. The way that we'll do that is using our inverse operations. So if we wanted an x by itself, we would have to do some stuff to my equation so that I could get rid of anything else that was happening to x. So we're going to do the opposite of whatever's happening to our variable to get rid of it. But an equation is kind of like a scale where we know these two things are equal to each other, and it starts off balanced. They're even. If I start doing something to one side of my equation, it's going to make one side more valuable or less valuable than the other. So what we have to do is, anytime we do something to one side of my equation, I also have to do that to the other side of my equation in order to balance it out. What you do to one side, you have to do to the other. So if I add something on the left side, I have to add that same thing on the right. Moving on to box 2, now we're going to be putting that into action. So in box 2, we're focusing on addition and subtraction. With number 1, the problem we're starting with is x minus 7 equals 3. So if I'm again trying to isolate my variable, I'm trying to get x by itself, right now I'm subtracting 7 from x. So if I wanted to do the inverse operation, I would do the opposite of subtraction, which would be addition. So I'm going to add 7. That's going to cancel those two things out, and I'm just literally left with x on the left side. But what I do on the left side, I also have to do on the right side. So I have to also add 7 on both sides. So my minus 7 and my plus 7 cancel out. I end up with just x equals 10. Continuing on with number 2, I'm starting off with m plus 48 equals 9.2. So here, now my variable is m, and I'm adding 4.8 to it. So I have to do the opposite of that, which is going to be subtracting that same number. When you do that, my 4.8s cancel out on the left side. I'm just left with m equals, now you can do mental math if you want to. You can do some scratch work off to the side, or as always, you can use a calculator. 9.2 minus 4.8 comes out to 4.4. Now something I didn't do on the first problem, but I want to do on all of my problems if I have time to, is check my answer. In order to check my answer here, I have to check and see whether the number I found was a solution. If it's a solution, remember that means I could plug that back into the original equation for my variable, and it would come out to be true. So if I put 4.4 in for m in the top of my equation here, 4.4 plus 4.8 does come out to 9.2, so I see that that does work. I solved correctly. Moving on to box 3. Box 3 is focusing on multiplication and division. Now this one looks a little bit confusing because for number 3, it looks like it's written as a fraction equals a number. So what I have to do here is be aware of my symbols. So there's a lot of different ways that math can be written because this is k over 5, but this is also the same thing as k divided by 5 equals -4, which makes it a lot easier for most of us to see if I'm dealing with a division problem, the inverse of that, the opposite of division, is multiplication. So if I'm trying to undo dividing by 5, I would multiply by 5. And again, whatever I do to one side, I have to do to the other. So those 5s cancel out on the left side. I end up with k equals -20, because -4 times 5 is -20. For number 4, I'm starting with 25j equals 75. Again, this is another sneaky one. I don't see an operation, but anytime something is written as a coefficient, meaning it's just a number out in front of a letter, and you don't see anything in between there, there's actually a little multiplication symbol hidden in there. If I've got 25 times j on the left side, I'm going to have to divide by 25 on both sides. Those cancel out on the left side. I am left with j equals 75 divided by 25 is just 3. Finally, box 4, we're focusing on real life problems, what you guys would probably call word problems. Now I want to go through a quick little set of strategies, a step-by-step guide on how you can be more successful in word problems, and then we'll do an example together. So when I'm going through and solving word problems, I always start with understanding what I'm being asked. So I have to go through and reread, use some of those strategies we talked about with our class expectations, but we have to make sure we understand what's the unknown, so what's the variable that I'm not sure of or that I'm going to be using in the problem. And then what am I asked? Am I asked to identify just x? Do I need to use it to solve another step of the problem? Once I have that variable, you have to be careful with word problems because they can be tricky at times. For step 2, we're going to make a plan. So this is where we actually go through and write an equation based on whatever information we're given. And then step 3, we're going to go ahead and solve that equation. So once we know what relationship we're dealing with and what we're asked to find, we can go ahead and solve for that variable. And finally, we're going to look back. We're going to go and check our answer, just like we did before. But also, in a word problem, it's important to check to see if the answer that you got makes sense in the context of the problem. If you're going through and trying to solve for how much you get paid every hour, and you come out to getting paid $1,500 an hour, more than likely you made a mistake somewhere along the way, because that doesn't make sense in the context of the problem for a job that normal people would have. So let's go ahead and finish up with number 5 here, which is a word problem. So in this one, Usain Bolt ran the 200-meter dash in 19.78 seconds, and they want us to write an equation and solve for his average speed. So first, we have to go through and identify what's the unknown and what am I asked to do. So here, pretty easy to see, the very last part of it, we're asked to solve for his average speed, which is an unknown. We don't know what that is. Step 2 is going to be identifying an equation, a relationship. We're trying to make a plan. If you aren't aware, if you don't remember it from middle school science, or if you haven't covered anything yet in physical science, if we're trying to calculate the speed of something, which I'm going to just use S for speed, the way I would do that is I would take how far they ran, their distance, and divide it by how long it took them to do that, the time. So speed is just distance over time. Knowing that, now we can plug in the things that we know into our equation to solve for S. We know that Usain Bolt ran a distance of 200 meters, and it took him 19.78 seconds. So if we use our calculators, or if you want to get really big brain and do it by hand, we should come out to 10.11 meters per second. Now here I rounded to 2 decimal places. That's pretty standard for rounding. Unless I say otherwise, that's where I want you guys to round to, is just the second decimal place. Also notice I did include the units. That is very, very important. If you're given units, your answer has to include units. That's it for today. Your homework, your classwork tomorrow that you're going to have some time in class to work on is pages 8 and 9, and you'll be working on numbers 6 through 40, just the evens. If you have any questions, make sure you have those right at the beginning of class tomorrow. Let me know if you have any questions, and I'll see you guys tomorrow.